Sorting number can be tricky, but how can I make it faster?
You can use bucket sort.
So what is bucket sort? The bucket sort is a sorting algorithm categorized under distribution sorts or non-comparison sorts. Presented in 1959 by Donald L. Shell, it has been one of the oldest sort methods until now. Unlike many other sorting algorithms which rely on comparing parts of elements, bucket sort operates by distributing elements into various buckets based on their values.
What are the process of bucket sort?
The bucket sort algorithm operates by first determining the range of the input data and then creating a fixed number of empty buckets. So in this example, we have here an array. So first, in order for us to sort this array using bucket sort algorithm, we first create a buckets. So here we create 5 buckets for the array. The number of buckets is usually based on either the number of elements or the range of the input data. Each buckets cover a specific range of values which we define based on our needs. Next, we distribute the elements into the appropriate buckets according to their values. Since we know the range for each bucket, we can easily determine where each number should go. After that, we sort each individual bucket. Since the number of elements in each bucket is usually small, we can use simple sorting algorithm like insertion sort or even built-in sorting function. Finally, we merge all the buckets in order, and the result is fully sorted array.
Now let's talk about the bucket sorts time complexity. Now let's head on to the bucket sorts big O notation. The time complexity of the bucket sort algorithm is typically described by its average case, which is O n plus key, where n is the number of the elements to be sorted and key is the number of buckets to be used. This means that on average, the time taken by the algorithm grows linearly with the number of the elements plus the number of the buckets. This efficiency is achieved when the input data is uniformly distributed over the range, resulting in a small, constant number of elements per bucket. Sorting these small buckets along with the initial distribution and final concatenation steps both leads to the complexity. However, in the worst case, if the input data is not uniformly distributed and all or most elements fall into single bucket, the time complexity degrades to 0 and 2. This worst case scenario arises because the step of sorting elements within that single dominant bucket, typically done using an OM2 algorithm like insertion sort, where M is the size of the bucket, becomes the dominant factor, essentially requiring an ON2 sort on the entire list.
Bucket sort is a fast and efficient algorithm when the input data is evenly spread out. It works by dividing the elements into different buckets and sorting each bucket individually. This makes it great for sorting floating point numbers and allows it to run very quickly. Sometimes, even in linear time, it also works well with parallel processing since the buckets can be sorted at the same time. However, bucket sort has some drawbacks. It doesn't perform well if the data isn't evenly distributed, and it needs extra memory to store the buckets. It's also hard to tune. Choosing the wrong number of buckets can slow it down. Lastly, it doesn't handle large range of numbers efficiently and usually needs another sorting method inside each bucket.
Hi everyone, welcome to my presentation on a really cool and simple Java algorithm, the bucket sort. But with a twist, we're using it to sort products by price. We'll go through the code line by line, explain what each part does, and even test it with real input. This is going to be fun, so let's jump in. I'm Gian Villarente, your presenter for this video. Let's get started. Here we have the Java code. We have the package bucket sort semicolon, import java.util.asterisk semicolon, and the class product. First, we need a way to represent each product. That's where the product class comes in, which has the string name semicolon and the double price semicolon. Next is we have the product. Each product has a name and a price. These are the details we want to work with. This part, it is the constructor. It helps us create a new product and initialize its name and price. While this, the toString, close and open parenthesis, is used when we print the product. It shows the name, the price, the range, and the price range of the product. Next is the getRange. The getRange method determines which price category the product belongs to. For example, if a product $5, it's in the 0 to 10 range. Okay? Next is the bucket sort method. Now, let's look at the main logic, the bucket sort. Here, this part, if there are no products, we simply stop, nothing to sort. While here, this part, we find the maximum price. This helps us spread products across buckets properly. While this, we chose the number of buckets based on the square root of the number of products. This is a common technique in bucket sort. While this, here we create the number of empty buckets. Each bucket will hold a group of similar price buckets. In this part, now we place each product into a bucket based on its price. It's like sorting groceries into different shelves by value. Okay, got it? Next. In this part, we sort each bucket individually using Java's built-in sort and combine them all back into the original list. Now everything is sorted by the price. And here we go to the main method. It is the user input and output. Let's move to the main method. This is where the magic begins. First, we use Conner to take input from the user and create a list to store our products. Next, in this part, we ask how many products the user wants to enter. Next line, in a loop, we ask the user to enter the name and price of each product and add it to our list. In this, we now call our bucket sort method to sort the products. And the last part, finally, we print out each product. Thanks to toString, it prints name, price, and price range all in one go. Now, let's try to run the code. Well, we have to put example, name of products, number of products, 4. Product name, Apple. The price will be 12. Next is laptop. The price will be $8.99. Next is book. The price will be 5. And the last one will be headphones. Price will be $49. Here's what the code output looks like. So you can see that the products are now sorted by the price and their price range is shown clearly, easy to read and even easier to manage. And that's it. Today, we'll learn how to sort products by price using bucket sort in Java. We created a class to represent the products, divided them into buckets based on price, sorted each bucket, and printed a neat formatted list. This is a great example of combining real-world data like shopping prices with a sorting algorithm. I hope this helped you understand bucket sort in a fun and practical way. I'm Gian Jubilirente, and thank you so much for watching my presentation. If you found this helpful, feel free to like, share, or even code along. Happy coding and see you next time. Bye!
Remember, distribute into buckets.
Sort each bucket.
Merge the result.
And that's the power of
Bucket sort!
Ito, boys and